So here we are thinking about Kepler's third law, which is thinking about the comparison between T and R using this formula. Again, T is that orbital period, which is measuring the time it takes for one full orbit. So that's why it's labeled with a T. So orbital period is measured in years. Our R then is thinking about radius, and remember that's an average distance from the center or the star in the middle to the outer edge, right? So it's that average because, every single distance is a little bit different. And that is measured in AU, astronomical units. So for this formula, we either will know the time it takes to make one orbit and can solve for the distance from the sun, or if we know the average distance, we can then solve for the years it takes to orbit. So either way, got to think about what we know and what we need. So looking at the question, we are wanting to calculate for orbital period. So that means we're trying to solve for T. So if we're trying to solve for T, I should have an R that I can then plug into my formula. And that's exactly what you're going to see for all of these calculations. Is R, got to be solving for T. So I put an outline here to help us kind of chunk out the steps using the formula to get to T. Up to you if you want to copy paste this into all the examples, or if you just want to do one with us and then kind of keep going. So here we go. For starters, like we said, we know we're solving for T, so that means I need to figure out what my R value is. I need to plug in. Well, that's what was given to me here. So I'm plugging that number in. 1.65 AU is my R. And at this point, I can't do anything on the T side, but what I can do is solve for the R side. So I am just going to simply plug this in to the calculator. So that means I need to access I've been using this one, the Google Scientific Calculator, super helpful. Use what works for you. So on this particular one, the button I need first is this, allowing me to put in any exponent up here, which for us to start is a 3. So I need 1.65, the number I was given for R, and according to the formula, I need to cube that. So to the power of 3. And I'm sticking with my rounding to 3 decimals. So looking at that fourth decimal as a 1, I don't need to round anything, and I'm all set with 4.492. So now that I have my new value for R cubed, I'm down to T squared equals this number. But I'm not finished because I need T all alone. T is still squared here. So again, the other button we were working with on the calculator was this one, the square root. And the square root reverses the square. So here, looking at our formula, I've got T by itself, and I want to take the square root of this new number I just calculated, 4.492. So back on my calculator, clear it out, square root first, type that in, 4.492, double check that I typed it correctly, hit equals, and again rounding to that third decimal, 2.119. And remember, that is a measurement in years for time it takes to do one orbital period. So following the same setup for moon number 2, I have my orbital radius given to me. So I'm starting again with T squared equals my number given, cubed. Plugging that into my calculator gives me t squared equals, let's see, 3.75 to the third power. So big one here, 52.734. So that fourth number is a 3, so it doesn't round at all. So I keep my 734. To reverse my square, I've got to do square root of that number. So plugging that in, square root, 52734. Double checking I typed it in, and t equals 7.26. Now I'm looking at my fourth number is an 8, so that will round up to a 2. So I've got 2 answers so far. 1, 2. So we're always given the r here, so every time is going to start the same. T squared equals my r cubed. Whatever number I get then needs to be square rooted, right? These two are the same number, so I can get t all by itself. So keep going with those calculations, and then number 4 is putting those numbers, the orbital periods we just calculated, in order, smallest to biggest, and what that tells me about the relationship between those two things.